Okay, so today we're going to start looking at conditional probability and the multiplication rule. So in this section, you're going to learn how to find the probability when two events occur in sequence. So the first thing we need to look at is conditional probability. And this is the probability of an event occurring given that another event has already occurred. The conditional probability of event B occurring given event A has occurred is denoted capital P, parenthesis B, and then a vertical line which represents given A. And this is said the probability of B given A. Okay, so that vertical line means given. So an example, two cards are selected in sequence from a standard deck. Find the probability that the second card is a queen. Given that the first card is a king, assume that the king is not replaced. So we're finding the probability of queen given a king was already chosen. Okay, so how many queens are there? 4. And if that king wasn't replaced, remember there's 52 cards in a deck. If it's not replaced, that leaves 51. And if we divide and round, we get 0.078. Okay, so the table shows the results of a survey in which 2,276 social media users were asked whether they have ever been offended by something they saw on social media. Okay, so we have this table. So first thing we're going to do, let's find the probability that the user was not offended by something on social media. Okay. So the probability of not offended okay. So since we're looking at a table, our not offended is the 1,125 out of the 2,276. And if we round that, we get 0.494. Okay, so this is actually one from 3.1. Looking at the empirical rule, since we have data, or not empirical rule. I just blanked on what I'm saying. Empirical probability. There we go. Okay. Number 2, find the probability that a user is male given that the user was offended. So the probability of male given offended. Okay. So we're going to start off with our denominator. Okay. And that's based off the offended. So we're looking back at our table and looking at how many were offended, okay? And that is the 1,151. Okay, and of those 1,151, how many were male? That would be 532. If we go ahead and divide and round, we get 0.462. Okay. Part 3, find the probability that a user is female, given that the user was not offended by something on social media. So we're finding the probability of female given not offended. Okay. So looking back at the table, how many were not offended? And that's that 1,125. That's our denominator. And of those 1,125, how many are female? And that would be the 549. We divide and round to 3 decimal places, we get 0.488. Okay, so now we're going to look at independent and dependent events. So in some experiments, one event does not occur the probability of another. So for an example, if we toss a coin and we roll a die, okay, tossing a coin is not going to affect what we get when we roll a die. So those two events are independent. You use conditional probabilities to determine whether events are independent. So our definition of independent is when the occurrence of two events does not affect the probability of the occurrence of the other event. So we could say the probability of B given event A already happened is simply the probability of event B, and the probability of event A given event B equals the probability of event A. Okay. Dependent, this is just events are not independent. The book has a great definition for it. All right, so let's look at these examples. Decide whether the events are independent or dependent. So selecting a king from a standard deck, not replacing it, and then selecting a queen from the deck. So this is similar to that first example we did on the previous page. So if we do this, the probability of getting a queen, given we already drew a king, okay, we know from our previous page was 4/51. Okay, remember there's 4 queens, there's 52 cards in the deck. If we don't replace the king, we're left with 51. Then the probability of just drawing a queen, given nothing else, would be the 4 out of the total deck 52. Since these are not equal, it's dependent. Okay. And the key reason here is because we didn't replace. The first card. Okay, so I want you to try 2 and 3, see what you think, and then we'll talk about those in class.